Assalamualaikum warahmatullahi wabarakatuh, and hello. So we are from Group 8. We'll be presenting our PBL group project that has been lectured by Technologist Dr. Ahmad Fatih bin Muhammad Noor from section 3. Before I begin our presentation, I would like to introduce my groupmate that consists of 4 persons, including me, myself. My name is Nur Nabila binti Aidil with metric number DE20081. That would be the chairperson for this group project. The next person is Nur Syahira binti Ahmad Safawi, that will be my secretary. And the third person is Muhammad Fairuz bin Muhammad Noor, the role is business support manager. And the last person is Muhammad Afiq bin Badrul Hisham, that will be the manager. So I would like to beginning our presentation with an introduction. So the project background of this PBL is solar PV is one of the most widely used DGs owing to its numerous benefits, including abundant primary energy from the sun, simple installation and setup, sufficient technologies for deployment for both industrial and domestic purposes. However, like other weather-dependent DG systems, solar PV from output uncertainties which can generate both technical and economic problem if not properly planned and built. Due to the current unbundling rules and the deregulation of the electricity business, DG owners or investor, not power system operator, can effectively design the location and amount of DGs. However, in recent years, upgrading of the power system structure has become critical because of the increased demand of the electrical energy, which has forced the necessity to switch from the centralized to decentralized generation small power generation units. Okay, so I would like to proceed to the next slide, which will be the objective of our PBL, to analyze the effect of the approach on the real and reactive power losses within the network as well as the bus voltage profile. So the next point is to estimate the backward or forward swap load flow for a radial distribution. And the third one, to get and to know the solar PV modeling and DG injection approach to obtain an estimate of the net power injectable from the solar PV DGs. And the last objective is to solve the problem formulation and DG modeling using the backward or forward swap approach information. Next is the literature review. From the research and the review that we have made, we know that the goal of optimal DC placement is to give the best size and sizes of DG units for overall network performance improvement, such as increased dependability, minimal active power losses, improved voltage profile, lower operating costs, environmental sustainable, and so on. In this work, photovoltaic is integrated into the IEEE 33 bus RDN standard by establishing the safe amount for real power injection by monitoring essential steady-state distribution system performance using the site's capacity factor. Although PV can inject the reactive power into the system through the inverter in accordance with the current down and grid regulation, distribution system's performance on actual and reactive power losses as well as bus voltage was examined and compared to similar works of literature. Few optimization tools have been presented in the literature for determining the optimal location and sizing of DG in the distribution network for improved network performance. Since the methodology approaches, often known as evolutionary algorithm, are based on the use of artificial intelligence technique, including the genetic algorithm, particle swarm optimization, taboo search, and others. So that's all from me. The other content will be proceeded by my group.
My name is Muhammad Fairuz. In this part, I will explain about meteorology. At the meteorology, the characteristic of distribution conductors such as a height resistance to reactance ratio and a radial form with many nodes, branch DGS, and a complex layout make it difficult to handle using this method. And in this methodology, we have a method for the first is a backward forward sweep load flow for a radial. In this part, the fundamental properties of the radial network and the actual and reactive power flows and losses in a simplified radial distribution network RDN. For the second part, solar PV modeling and DG injection approach. First, solar photovoltaic model the PV output at any instantaneous time and to obtain an estimate of the net power injectable from the solar PV DG. And for the third, problem formulation and DG modeling. In this part, active power and reactive power losses and the voltage at each node in the RDN are evaluated using a backward-forward sweep approach. For the last part is evolutionary optimization algorithm. For in this part, particle swarm optimization (PSO) is adopted in this research. and effective method for solving diverse complex nonlinear optimization problems.
Assalamualaikum and hi, my name is Muhammad Afiq bin Badrul Hisam. So today I would like to talk about our coding for bus 30. Okay, the start here is from the starting. We get the load for P is 10.6 and load Q is 1.9. So after we run, so we can see here the voltage bus is 0.995 pu. Okay, then I increase this value to 10%. So you see, again, and we will see the voltage has changed and decreased to 0.971. Okay, next I increase 10% more. Again, so the voltage at the bus 30 is 0.935. So after that, up to 10% again. And run. Here is the voltage PU. So it also decrease more. After that, we will 10% until the system is collapsed. So now 31.8 is 5.7. Still the same, but this we get bus 30 0.858. Okay, the system still not collapse, so I increase 10% more. And yeah, we see the bus 30 is 0.810. As we can see here also, the more load, the higher the load, so the lower the voltage will be. Next, we increase the load again. 0.6. This one 2.4. Okay, here we get 0.731. Okay. This is where the system will collapse. As you can see, the commando, it cannot generate the system. So what we must do is we must do the previous system because the system has collapsed. So I starting from 10. And we run the system. As you can see here, it can run again, but the number is not within the range value. So I increase by 5 value. So 15 we run. Here we get 0.823, still not in the within the range, which is 0.9 and 1.1. So I increase 20, and again, here we get 0.856, not stabilized. So we increase to 25. Here we get 0.889. But actually not satisfied, so I increase to 30. So here we get 0.912. The value voltage at bus 30 is within the range for 0.9 and 1.1. So it has stabilized the system now. So for this, we have used the 30 value of voltage for the to generate this system, because when this value, this load value, the system has collapsed. So we add 30 in the previous system. Okay, I think that's all for me. Thank you. I would like to discuss about result on the photovoltaic generator power value. So first, the result solution chosen to mitigate the problem is to install photovoltaic distributed generation at bus 30. The power generation of photovoltaic distribution generation PVDG is applied and the power generation will be added in the system. We are using value 10 milliwatt. The voltage per unit that we get for 10 milliwatt is 0.783 per unit. Okay, next, the value of voltage per unit will increase if the power of photovoltaic increase. If power of photovoltaic is added in the system, it will help the system to generate again within the allowable range, which is between 0.9 and 1.1. So the allowable voltage is 30 milliwatt, which is the value is 0.912 per unit. Next, on MATLAB, we use the T-bus system for this project simulation. The data that we referred is not exactly same with our project, but it is almost same. The load demand at bus 30 is we increase it by 10% due to incrementation of building in that area. The range of the allowable voltage is 0.9 to 1.1 per unit only. Therefore, the system will collapse and cannot generate power at this load. Next is we can see that the value of voltage per unit is decreasing when the value of load is increasing. So the solution for this problem is we must add in the photovoltaic, which is renewable energy, as a power generation for this system at bus 30. So next, I would like to talk about advantage of PVDG implementation. Avoidance or reduction of emission and distribution cost, decrease of repower loss. supply of backup power in event of utility failure, and overall enhancement of network dependability. First is distribution generation is properly positioned and sized in distribution network. The point is improper DG placement in distribution network can result in issue. Second is transmission and submission network account for roughly 30% of total power losses in electric power system. Okay, second is distribution network losses can lead to a poor voltage profile, particularly when the load is high. Second point is traditional loss reduction solution does focus on network reconfiguration. The third is strategically putting and scaling DG at well selected buses can cut system power losses. So the third point is energy storage facility can be built. The point is to reduce reverse power flow, which can be dangerous to power system. And the second point is ensure that demand increases can be met in a cost-effective, safe, and dependable manner. Lastly is the most widely used DG at abundant primary energy from the sun, ease of installation and setup, sufficient technology for both industrial can cause both technical and financial issue if not properly planned and constructed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nusha binti Ahmad Safawi. My matrix number is BE20303. So today I will explain about the conclusion. Firstly, I will explain about the attainment of project objective. So the primary of this project was to develop the effect of the approach on the real and reactive power losses within the network as well as the bus voltage profile. So all the objective has been successfully achieved as attached in the result and discussion. And next, the performance of the power system can be essential accessed by the customer at the distribution end of the network. So next, we devote to improve the quality and reliability of the power supply to the consumer loads by optimal deployment of the distributed generators. So next, I will explain about the highlight of this project finding. So firstly, we make the methodology of the time series power flow analysis more readily and accessible to the utilities. Second, for evaluating the potential impact of the high level of PV on the distribution system. Third, know how it can increase the load demand effect the power flow of the system by doing this project. Lastly, I will explain about the recommendation of future works. Develop solar energy grids integration system that incorporates advanced integrates inverter, storage and energy management system that can support communication protocol used by energy management and utility distribution level system. So first, we need to develop advanced integrated inverter hardware. Second, we need to do research and develop regulation concept. Third, we need to identify inverter type storage system. And lastly, we need to investigate DC power distribution architectures. That's all from me. Thank you.